Okay, one last example for this particular section. So we're trying to find all the missing angles and lengths for this. This kind of seems like we have like two ropes that are attached to each other, and there's a force pulling them down. What's that force? How do we solve with forces? We're not there yet. We'll get there soon. But first off, let's focus on these lengths and see if we can solve that. Now, I see that this looks like a right triangle, and since there's no other right triangles given, I'm going to have to assume that that's a right triangle because it just makes sense for it to be. I've got two lengths, and I'm going to go ahead and find this third one. How am I going to do it? Pythagorean theorem. So this guy's called B, which throws off our things, but we'll just go ahead and do that anyway. So we'll call this side A, we'll call this side C. And so a squared plus c squared is equal to b squared this time, just because this guy was already named b. You can switch it and name it c if you want to. You could have easily just marked through this. You know, I probably should have just said that's c. But c is somewhere else, so we're kind of going to throwing our things off if we do too much here. I got to give things new names. Oh, that's going to be painful. We'll call this guy x and this guy y. There we go. So x squared plus y squared is equal to b squared. That can work. We can do that. So what is x squared? Well, that would be 4 squared, which is 16. What is y squared? Well, that is 144, because that's 12 squared. And that's equal to b squared. So I add those two together. What do I get 160. And so what is b? B is going to be equal to the square root of 160. So let's figure that out. Square root of 160, what are you? And it says 12.65. And we have it. So this one right here is 12.65. Okay, so we got that. That helps us out. Now, let's figure out the angles that we're missing. Now, we're missing quite a few angles, but these aren't going to be too terribly difficult to get in the end. Let's start with the question mark angle. Why not? We can do it. We have three sides. We need an angle. And guess what? Law of cosines can give it to us. We've got lots of sides. Law of cosine typically works well. So c squared is equal to a squared plus b squared minus 2ab cosine of c. And as a note, that angle right there is going to be c. And oh no, my notation's off because of how these things are ordered. Oh, that's terrible. I'll rewrite it. I'll do it the right way. Okay, so b squared, because that's what that is called, is equal to c squared plus a squared minus 2ac cosine of b. There we go. I know you're all happy now. I wrote it the right way. So let's plug that in there. First off, 12.65 squared. What are you? That comes out to be exactly 160. I should have known that because I was like literally a second ago. Equals c squared, which is 64, plus a squared, which is 36, minus 2 times 8 times 6 cosine of b, which I do not know. And so I'm going to plug in all of this into my calculator first. So 160 minus 100, that's a pretty easy one. It's just going to be 60. So 60 is equal to negative 2 times 8 times 6, that would be negative 96 cosine of b. Okay, we're doing good here. This looks pretty good to me. And I'm making mistakes in my signs. I don't believe I did. Nice. So what's 60 divided by negative 96? So 60 divided by negative 96 is equal to negative 0.625. So cosine of b is equal to negative 0.625. Looks good. And so b is going to be equal to cosine to the negative first of negative 0.625. Let's plug in our calculator and see what we get. Shift cosine negative 0.625. And I get 128.6. Nice. Loving this. It's equal to 128 well, actually be 7 degrees. So that's what I have here, 128.7 degrees. Perfection. It looks good. Okay, so let's keep on going and see if we can solve the rest of this. Okay, so we have one of the angles here. We need two more angles, so let's go ahead and solve for this one right here. And this time I'm going to use law of sines to work with it. So let's see, A, which is 6, over sine of theta, which I don't know, is equal to B, yes, B, which is 12.65, over sine of 128.7. 128.7. There we go. That looks fine. Okay. And what do I get? I get, let's see here, we've got to rearrange things a little bit. So I'm going to multiply both sides by sine of theta. And then I'm going to divide both sides by this guy. So what that'll get me in the end is I will have sine of theta. I won't put it on the line there, that's going to mess with people's eyes. Sine of theta is equal to 6 sine of 128.7 all over 12.65. Okay, and our angle theta will hopefully come out to be something reasonable. We'll find out. So, let's see, second sine, 6 divided by 12.65 times sine of 128.7. And I get 21.7 degrees. Okay, so I've got two of these. Now I need the third, and I know there's 180 degrees in a triangle, so let's solve for this angle. So theta plus 128.7 plus 21.7 is equal to 180. Therefore theta is equal to, what are you equal to? 68.3. Fantastic. So with that, we got all the missing sides and angles for the important bits of this guy. We could do the rest, but I'm going to stop here for the moment. However, before I go, I do want to bring up one note. So in a previous video, I mentioned that sine to the negative first of, x will never, ever, ever be more than 90. It'll always be equal to or less than 90. And I'm talking about the absolute values there. Now what you notice though is when we did our cosine, we were able to get that value and get it nicely. We got 128.7, it just popped it out. So you can just use your brain. Like I could have done law of sines and realized when I got an angle here that it should have been more than 90 and fixed it like we did previously. But you can also just use law of cosines if you need to, and it will often pop out the angle just perfectly. So just a note for the future. Thank you all so much. See you later. Bye-bye.